All right, so welcome to the final presentation of today. And I mean, I was thinking about starting this with something like, welcome to Cephalocon 2024. So this is going to be the third presentation on working with, running on, sharing Ceph. So yeah, really interesting. So today I'm going to give an update on things that I've already had presentations on last year's SambaXP and also at SDC. That's near SDC in September. And that is basically something that I couldn't say better than David Düsseldorf did back in 2019. So this is a quote from David Düsseldorf. David, are you around by chance? I think I didn't see him in the list of participants, so he's probably not here. So David Düsseldorf from the Samba team from SUSE. He kind of, I think, later joined by Samuel Cabrero, also from the SUSE team, started this venture back then. And I'm just going to read this for you. So Ceph as a replacement for CTDB key value storage. Ceph offers a highly scalable and fault-tolerant storage system. Samba is already capable of sharing data located on the Ceph file system. However, scale-out sharing, the same data exposed by multiple Samba nodes, currently requires the use of CTDB for consistent and coherent state across Samba cluster. In such a setup, CTDB provides a clustered database with persistent key value data storage and locking. Database usage is abstracted out via a generic dbwrap interface. So that's an interface that Samba uses to talk to database backend. Ceph's Librados library provides an API for the storage and retrieval of arbitrary key value data via the OMAP functions. A watch notify protocol is also provided as a mechanism for synchronizing client state, including locking. Key value data stored in the Rados backend inherits the same redundancy features as regular objects, making it a potentially good candidate as a replacement for CTDB in Scale or Samba. So this is from 2019, and it was back then something that SUSE has been running for projects with their engineers. They call Hack Week, where developers are given the opportunity to use some of their time to work on some exciting new stuff. And this was one of them back then. And so last year, when I also started to think about what can we do, maybe looking at databases that we could use in Samba, is what about Ceph? And then I came across this project from David and later Samuel, and this was then one of the databases I used last year when benchmarking several distributed databases. And unfortunately, this was very much a complete fail. So before going into the results, a quick info on the actual benchmark that I was using and I will be using here today also. And the benchmark, what I'm really doing here is really hammering the Samba server via the SMB protocol, just opening and closing the same file in a loop from a configurable amount of client. So this is a bit misleading, the option name and procs. It's actually just all running inside a single SMB torture process, and that process just spawns a configurable number of TCP and then SMB sessions against a server. And that server is actually not only going to be a single IP address, a single server, it's actually going to be a list of servers that's going to be passed via this this text file here, via the parameter UNC list for SMB torture. And that's a way of basically allowing the connections to be spread out against CTDB nodes in a Samba cluster. So for my tests, I basically used a very simple Samba cluster with 3 nodes. So in this UNC list text file, I just specified then I'm not showing it here. I'm sorry. Maybe I should have done that. Just the list of the 3 IP addresses of the CTDB nodes. And that's basically the benchmark. And doing these SMB open and close is what hammers then the backend code in the backend subsystem in Samba, where we go via our dbwrap database abstraction backend to talk to a database that maintains this file handle state. Okay. And I ran this against a bunch of databases last year, and one of them was Ceph, and this was the result. I mean, this looks a little bit like how do you call that? A deadline on an EKG in German. I think it's not actually 0. I think it was something like maybe 40 or 50 or something like that. So basically, if you on the x-axis, we see the number of clients increasing via this parameter I showed on the previous slide, going up from 1 up to 500, I think 500 clients using a logarithmic scale here. And what I was kind of expecting basically, and that what we saw also with the other databases that are used in testing, is this a single connection, a single client will of course have a specific latency for each open and close request, such that the number of open and closes per single client might be not that high, but the total number of open closes, and what you see on the y-axis here is the total number of open closes on the whole cluster. That should scale in some way at least, and not just stay down at the bottom there and actually decrease with the number of clients. So that was last year. So this year I redid the whole thing, and woohoo, this is what we get, much better. And so up to, what is it? I think it was close to 3,000 total aggregate open and close with 500 clients. So much better. And I'm not sharing all the results. I didn't want to make this graph too complicated with also bringing up the results from all the other databases that we tested last year. So this is just much better. And the thing that we now want to compare this against, of course, is wrong direction. This one. Compare it against CTDB itself. And unfortunately, this doesn't look so good, right? So with CTDB, you see some maximum at the number of something like 20 clients. You get a whopping 30,000 open and closes per second. And I think that the maximum with Ceph here on the far right is something like, going back to the previous slide, something like 3,000. So it's much better, and it's more or less in the ranges of, actually a bit better than for example, comparing this with the etcd distributed database that is used by Kubernetes internally. But it's much lower. So, I mean, why all this? If CTDB is so much faster, why actually thinking about replacing it? And the thing is,
one question, if I may, real quick. So you're exchanging CTDB with Rados as a key value store, but
exactly.
What is the file system? Is it Ceph itself, since you anyway have Ceph?
Or what the file system is just actually local.
Local, okay.
So I'm not sharing, so yeah, I don't care about file system here, really. I just want to handle the database. So I'm not sharing a cluster file system. I'm just sharing a local ext4 or XFS, I don't remember, on the CTDB node.
Okay, thanks for clarifying that.
Yeah, okay.
It helps a lot.
And yeah, if you want more details, I'm actually, all clients are passing the same path. So they would all be actually like opening the same file, which would be like they all would be contending on the same file, which would be also contending then on the same record in the database. And that's not what I want. What I want is non-concurrent access to files in my workload. Because concurrent access, if all those clients just hammer on the same file and hammer on the same record on the database, this is going to suck no matter what. So what I'm more interested in is to get an understanding if, presumably, if the SMB workload is mostly non-concurrent, what kind of maximum performance can we expect? Okay. So, and to achieve this, I used a few tricks in the Samba configuration, basically using the VFS file ID module to trick every open on that file to, in the end, go to a different database record, so that I can completely avoid contention on database record. Okay. So continuing, yeah, on trying to give an answer on, yeah, why actually looking at replacing CTDB, and it basically starts here with the second point. CTDB cheats. Data is not replicated, at least as far as the records that store file handle state is concerned. And this is a problem, particularly for SMB3 persistent handles. So for the SMB3 persistent handle features, we need the file handle states to be replicated across nodes in the cluster. And CTDB just currently does not do that. So one thing, of course, that could be done is try to come up with ways how this could be implemented in CTDB. And actually, I gave a presentation of a possible approach there. I think it was in 2018 or something like that. But this time, I wanted to attack this from a different angle and just look if maybe there's any existing distributed database out there that could fit the bill, right? So going back now to these tests here using Ceph for the key value store for the database. So what changed from 2023 to this year? And so in 2023, last year, I was basically using an existing backend from Samuel from Suzy. He wrote a proper, fully functional working backend in C that would talk to Ceph radars and can be used then as a database key value store with Samba. And for some reason, with the specific approach chosen in the code, which is briefly touched here in the third point, where we were using a Ceph OMAP on a single object per Samba database. And this, for some reason, turned out to be, yeah, not really working at all. So what I changed this year is basically I added a completely new Ceph radars backend written in Python. And that Python code is basically just then the backend infrastructure code that is called by a dbwrap Python module in dbwrap module in Samba. And that was basically done by me last year, writing this dbwrap _py C. It's written in C. dbwrap backend in order to do rapid prototyping for all the different distributed databases. So what I did this year is I just quickly sat down and rewrote basically the C code in Python. And I think I have it somewhere on the next slide. It's just something like 100 or 150 lines. It's not really complete. It doesn't do persistent records. It doesn't do traverses and so listing records and much more so. But yeah, I mean, you're probably all aware of that Python is a lot more terse than C. So I was basically could write this backend in Python in something like a few hours or maybe a day. And then having this written in Python, I could also then make some changes easily, like tuning the ratio of how many OMAPs and objects, or would we be using just objects instead of OMAPs? That can easily be tested in Python. So the question is then probably for some of you, what is a Ceph OMAP? So this is a quote from the Ceph documentation. So OMAP it's basically a key value store that Ceph routers implements on each node. It's associated on the API level with each object. So which means in a way the key of an object is then combined with the key you provide as the key for the OMAP. But in the end, everything is just stored in one low-level key value store per OSD. And I think this quote here is not from the latest release; it's from an older one, which still says in the Ceph Hammer release, LevelDB was used as the database. And in the recent documentation, this was just changed to, we use some database in the background, but we don't tell you which one. So that's the Ceph OMAP. So it's basically a way of storing small key value pairs in an actual database in Ceph, and it's used by Ceph internally for object metadata and for CephFS, as far as I know. So it was, of course, an obvious choice to build, to export this externally as a key value store for Samba, to also store the Samba records then in the end in this Ceph OMAP database. Maybe some of you are also not really familiar what is a Ceph OSD. And so the Ceph OSD it's kind of like a daemon or several daemons per Ceph storage node. And the Ceph storage nodes, I think they are also called the Ceph OSDs. And those are the one where you would basically have your storage devices. And so the Ceph OSDs, the daemons, and I think the whole nodes are also just called OSDs, are the ones that store the actual data. And that is then either S3 objects or like also the OMAPs mentioned above. So now using Ceph as a backend basically as a backend for a key value database, this gives us the choice whether to store our records either just as regular objects, as S3 objects via the Rados API in Ceph, in LibRados, or as mentioned before, just store them in this OMAP database, which is basically kind of built for that purpose. So I was then really interested to do a comparison of the different methods, and we will see some results of that on the next slide. And some downsides of using objects directly is, from what I've been told, and we won't really see that in the numbers actually, which is interesting, but that might also be related to just the test hardware that I was using. But in theory, using objects as storage could be slower for several reasons, and one of them is that in Ceph you can Probably, I'm not really familiar with low-level details of Ceph there with the configuration. You can probably do some kind of configuration in Ceph, which kind of object groups you want to store on faster devices and which ones you maybe want to store on slower devices. So if you might potentially run into problems here that the objects that we would be using here for a database would be then hosted on HDDs, which would be not ideal. Enumeration of the objects is supposed to be slower, which is also of some concern for us. And then there's actually then a metadata overhead for managing the object. So that metadata is actually going to be stored in OMAPs. So it's kind of like if we would be using just objects directly, we would write to OMAPs anyway. So in theory, it doesn't really make any sense to store our data in objects. But anyway, I tested it. And so I ran a few different configurations. I made this possible in the Python code to change between writing directly to Ceph objects instead of this OMAP database. And that's the green line. You see at the green line there mentioned at the top. And you see it's actually not the line at the bottom, which you might have expected. The blue line there at the bottom is actually using a Ceph OMAP associated with a single object. So as the OMAPs are tied to objects at the API layer in Ceph, and then internally, probably what is happening is that the requests are then sharded to different placement groups where the replication and storage of the data is actually happening, which is why, and that's what I've been told, and we can see this from the number, why increasing just the number of objects that you put in the request when you want to store a record in a Ceph OMAP scales to some extent increasing the number of objects. And there seems to be, at least in these tests, an optimum of at something like 1,000 objects. And then it goes down again a little bit. I haven't tested larger numbers that could be possible. But I think from this, at least the result is clear that just using OMAPs to store records is the right approach. I mean, using objects, at least in this test setup here, is surprisingly fast, I would say. But from this, I would then continue to say that probably using OMAP will make sense that it gives better performance. So there was Ceph and CTDB. So CTDB is just screamingly fast. Ceph, while it now works much better, from a performance perspective, it's still not there in my test setup here. There's a large gap, a very large gap, right? So then, I mean, basically coming back to what I already had presented last year, are there maybe even more databases or other approaches we could use? And so just quickly, also bringing up here the requirements that we have for a database that we want to use in Samba. So what we need is, for the consistency, we need a database with strong consistency. So either a non-transactional key value store, that means linearizability, or for transaction databases means strict serializability. We need atomic updates. We need distributed locking. We need this to serialize and isolate access to two resources, file system and database. So for example, when we create a file, we want to make this appear externally that this is an atomic operation. So when we store file handle state in a database and we actually create a file in the backing file system, this should ideally appear as an atomic operation to clients. So one way basically that we do to give this illusion is that all operations go serially via having to acquire a lock on the file associated database record. And I mean, ideally, and for my tests, most databases actually do provide Python bindings. And that was very helpful for actually doing all the fast prototyping I did last year, for being able to quickly set up test hardware with databases and then sitting down and spending a few hours on writing a Python backend that target those databases. And there are a lot of them. Not all of them fit our bill. There are those so-called eventually consistent databases, which basically means, yes, you can write a record, but it's not guaranteed that you're actually ever going to read it back. It might just go to dev null. Or another client might read that record, but then sometime later it will read an older version of the same record. And strange things can happen there, and that's not what we need. So only few of those databases are actually providing the required consistency semantics. And one of them we're going to look at on the next slide, just here quickly giving you an impression of how small those Python backends for talking to those databases actually are. So you see here, last year I had one for Apache Cassandra. This one is new this year for Ceph. This one is here for etcd. I funnily also wrote one here for Samba's own TDB. So this will then just go locally to our own TDB database. And this one is FoundationDB, and that's the one, hopefully, I'm continuing with on the next slide. FoundationDB is a key value store actually with transaction support. So it doesn't not only support single key operations, but you can have transaction working on multiple keys. It's supposedly highly scalable. It was basically originally also written by Apple and was used heavily by Apple in iCloud. I think Apple might have recently more moved to Apache Cassandra. This, I mean, that's something I think I picked up a few rumors about this, about how much it is used at Apple on certain database forums, but I mean, nobody really knows. They don't disclose this publicly, but at least they were using it heavily. And another user is Snowflake, which is a data warehouse cloud company. And they're using it to store the S3 object metadata. And that's, I mean, basically what Ceph OMAP is doing for Ceph. So in theory, this is exactly, I mean, the use case that we need, a fast distributed database. So last year, I did some benchmarks with FoundationDB at SambaXP, and then I did an update for SDC, where I was able to use a larger FoundationDB cluster. And you see here that we get something like 3 times as many requests and open close operations per second compared to Ceph. But it's still at least in the range with something like 20 clients where CTDB is really shining here with 30,000 operations per second. There's still a lot to be desired. But so the last days, I actually also rechecked what kind of test hardware here I was actually using, particularly looking at the storage, at the number of IOPS that were available to the servers I was using for the benchmarks. And so I ran a few FIO benchmarks. So using FIO with 4K IO size, random writes to a big random reads and writes to a big file with a read-write skew of 75% reads, which is just a random value. I could have chosen 50 or 25. Maybe 50% would have made more sense, because that's probably what you're going to see with the database access pattern. But it's really not really that important, because the main thing is basically this. So the FoundationDB cluster I was running there with Terraform in Azure in the cloud, I was throwing lots of nodes at the cluster and at the benchmark. I think the maximum I was trying to run the benchmark with was something like 32 nodes. And I didn't see any great scalability with increasing nodes. And overall, the performance left still a lot to be desired, given that FoundationDB was supposed to be really, really, really scalable. And I think the reason is just, I mean, what can you expect if you have just this that only provides 12K reads IOPS and 4K write IOPS at this 75%. So that's combined 60K IOPS per node, which is just ridiculous, right? And for the Ceph cluster I actually used now in these tests, there was basically running in a I mean, it's now Broadcom, right? So in an in a vCenter VM cluster, running in VMs. So I had 6 Ceph VMs. 3 of them were OSDs, and per OSD I had 1 storage device. And in the end, the whole vCenter virtual machine server cluster was basically attached to a 12 gigabyte SAS serial SCSI attached array that was capable of an aggregate something like 80,000 or maybe 90,000 IOPS per second. So when hammering the storage backends from 3 nodes, each node got a third of the total IOPS, and there was something like 36K. Yeah, so 36K by 3 is maybe 108,000. It was a bit more than 90,000, but this is still not really a lot. And another thing that I noticed was that when I then actually ran the SMB torture benchmark with the maximum value of 500 clients, I noticed that the disk was underutilized because a lot of IOPS merging was happening. So the Ceph OSD was queuing several requests in parallel to the device. So the queue size here was something like 5, but a lot of those requests got merged in the IOStat output, this column here, and that's write requests merged per second. So most of the write requests per second, and that was 8,000 on this node, most like 5,000 got merged, so that only 2,000 IOP requests were actually scheduled to the backend device, which IOStat still reports as 100% utilization, but this is not the total truth for a modern SSD, which can handle more than 1 request in parallel. And this, so the actual utilization of an SSD storage resource can only be judged by basically this parameter, the average queue size. And having values a lot higher than 1 is basically what you want here. And this is actually happening still on the device mapper device, which is the actual device used by the Ceph OSD. We have a queue size of close to 5 here, but all those requests get just folded and collapsed into a lot less requests, and which then results in serious underutilization of the SSD. And then when I noticed those numbers, I did some research on forums and on Ceph, and this is basically a known issue that currently the Ceph I/O scheduler on the OSDs is not capable of saturating SSDs or not even to think about NVMEs. The reported workaround there is to partition your SSD or your storage devices into multiple partitions and then having one OSD running per partition. So conclusion, the winner is still FoundationDB over Ceph, but yeah, as explained on the previous slide, both Ceph and FoundationDB performance and probably also, I haven't retested this again, probably also the numbers I got from benchmarking etcd, the distributed database by Kubernetes. They were just severely limited by the test hardware here I was using, right? So as explained for Ceph, just having VMs on a single physical server in the end, and FoundationDB, where I was using this in insanely slow disk on cloud VMs. And it's basically a known fact that just Ceph and FoundationDB database performance just heavily depends on this item. So what could you expect from these tests, right? What we really need to do is we need servers with a lot more scalable disk storage, NVMe SSDs, where you could. So I did some quick research, and I found like results where a single server was capable of serving like 10 million IOPS per server when using several NVMEs. So when running on some decent hardware, I would expect that performance would be at least a magnitude faster than the results that we have shown here, because it depends so much on the number of IOPS and disk latency. It's also somewhat network latency dependent, but it's mostly disk IOPS and latency. All right, and I think that's more or less then coming to a closing end here. A few links, and that's all for today. Thank you for listening. Are there any questions?
Hey, to start off with, I'm curious if you've thought about using your TDB wrapper stuff outside of just CTDB. Because I happen to have a Rados pool just sitting there ready to be used for various things.
I'm not sure I actually got that question. Can you try to put it differently?
Sure.
I can make sense of it. Sorry.
Just start with the use case
it's too late in the evening over here, probably, but I will do my best.
So certain databases, I'm thinking, for example, AutoRid database, I'd maybe like to actually store it in Rados instead of on a local disk. Can I use these wrapper scripts or libraries right now and point Samba to say, store this over here instead of in a file?
Good, yeah. I don't think so at the moment, at least not with some additional development effort, because as far as I remember, we don't use the dbwrap database abstraction in the ID mapping code. I think we talk to our low-level databases directly there, but I'm not 100%
I don't
sure.
think so. I mean, Ralph, so
yeah,
that's an aspect that hasn't been touched upon yet. That TDB or CTDB has basically two flavors of databases, the volatile and the persistent databases. And the volatile ones are the ones that you mainly focus on because those are the ones that hold that kind of temporary file open state. And the ID mapping databases and registry and others are the persistent ones that require transactional operations. And it's a good question whether you can basically use the Rados object also to plug dbwrap into it. If I'm not mistaken, dbwrap offers support for both. Right. Yeah, you should.
So yeah, I'm just not. It's late in the evening. I'm just now off top of the head. I'm not 100% sure if we're actually going through dbwrap everything in the ID mapping code. I mean, Michael, you probably know, or maybe Volker or Stefan.
Yeah, it's too long ago, so I probably forgot. If I'm not mistaken, we use dbwrap everywhere to access either volatile or persistent databases. So I'm pretty sure.
Not exactly everywhere, but everywhere that it matters.
Where it matters.
Okay.
So I mean, in particular, secrets.tdb, autorate, and if you ID map TDB, that's all going through. I mean, one thing that is not is Gencache, and a few others are the NetSambaXP cache that are really purely local, but all that potentially have to go through CTDB are, of course, passed through dbwrap.
dbwrap, yeah.
I'll ask hopefully a simpler question.
For example, also the ones, I mean, Winbind also uses volatile ones for the netlogon, let's update me, the netlogon credential chain, whatever, coordination.
Yeah, so to wrap this up, presumably you should be able to use it. So I mean, and I mean this, yeah, it's great that you bring this up because I actually wanted to touch upon this in my presentation about whether this is maybe exciting news for you because it means that you could avoid integrating CTDB into the stuff you're working on, right?
We'll see, you know, timelines and everything. But I'm personally really excited about it. I'd love to get my hands on it. I don't know if you heard, I did just try to ask if the Python code is in the tree. I just looked, I didn't see it. So maybe that's a first step, is to get these available more widely.
Yeah, I mean, currently it's all just sitting in my local branches. It's not in any way upstream yet. And I mean, if I get more requests that this should be put upstream because it's on some value for others, then I'd be more than happy to just do
well, I'm one vote for yes.
Yeah, it would be very useful for other people to experiment with it, I guess. That would be super cool. I mean, it doesn't need to be merged officially upstream, but to publish it somewhere, that would be great.
It is published, definitely. It's on gitsamba.org in my repository. Probably in several others as well, where I pushed it, but it's on gitsamba.org slow.git or something like that, where I have the branch. I could try to share them. I will put the link in my slides. Right, that's what I'm going to do. Yeah,
perfect. I have another question. Are you aware of the Ceph Crimson project? It's supposed to change the structure of the OSD so that it performs better on SSDs, in air quotes, modern hardware. Great. I have not used it myself, but it's coming at some point.
Okay,
it's a long work in progress, rewrite and refactoring of the OSD server code, I guess.
Yeah.
Yeah, great. Yeah, I actually ran across something that does SQL, some Ceph SQL stuff. That was interesting.
The embedded SQLite database?
Yeah, something like that.
Yeah, I was looking at that the other day.
That looked weird.
I don't think it'll help with concurrency. I believe it only allows one client at a time.
Yeah, that was my impression as well. Yeah. All right. Any more questions?
I mean, putting that upstream, even if it's just in a third party, you know, putting it in the main tree so people can get it will be more useful than having it in a branch that nobody knows exists except you. Sorry.
And everyone who watched this presentation, so
well, yes.
You also do about it. Okay, but I will see what I can do. Yeah.
I mean, obviously, it doesn't have to be in the main code path, but if you could do a third party, maybe, hey, here's how you set up dbwrap, Python wrappers. Here's what it is with just a README of how to do it. That would be.
I mean, it requires a few changes to the core dbwrap code in order to integrate cleanly also wire options, which backend then to use for which database, and so there's yeah.
Sure, that's why you could publish third party for now, until it was, and then maybe once it really gets integrated, move it into the core.
Oh, I can volunteer to help test it when you're ready to have someone else give it a whirl.
You could test now. I mean, I can send you the link for the Git repository, and then that would be actually getting more and more tests of this, and also actually, figuring out if it's actually useful besides just performance numbers. Does it fit your use case? And that would be actually very, 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 very helpful in order to get some real world feedback if this is something that could be helpful.
Cool.
Okay. Anyone else? No. Okay. Thanks a lot. So that means we are probably done for the day. No more presentations for today. I'm sorry. Sorry, go ahead.
I just said, yeah, dinner time now. Great stuff. Interesting presentation. Really great research work, Ralph. Thanks for that and sharing.
Thanks. You're welcome. So is there anything else anyone wants to bring up here late in the evening in Germany? We will have an open mic panel discussion tomorrow, so we probably don't want to spawn a full panel discussion right here today. But if anyone has any very, very urgent question, I'm happy to take or to give you the opportunity to bring up anything.